who's an associate professor at Corey College in computer science in Northeastern University, where he earned his PhD in computer science, or he earned his PhD in computer science and engineering at the University of Washington, has worked on video games, ProcGen, citizen science, crowdsourcing, one of the co-creators of Fold It, which I am a big fan of as a project, a way for citizens to contribute to scientific research in biochemistry. Super cool, but has also worked at Square Enix, Electronic Arts, Pixar Animation Studio, and is creative director of the Center for Game Science, and is here to talk about a tile rewrite language for building roguelikes. So, welcome, Seth.
Hello. Thanks. Can you hear me okay?
Yes, you sound good. Take it away.
All right. All right. Great. Thanks. So yeah, I'm Seth Cooper from Northeastern University, and I'm going to be talking a little bit about building a roguelike with a tile rewrite language. And so this is sort of like a new language that I've been developing with some collaborators. We're calling it TRRBT, rule behavior trees. It's kind of the name we've been using so far. And this is a language we're developing intended for programming sort of grid and turn-based games. And, we hope that maybe the language will make game programming a little bit different, a little bit more approachable, sort of like a different way of thinking about programming games that might make it kind of interesting in a different way. And so we're really trying to make things in the language sort of able to be done visually. The game state, basically, for a game is just represented essentially as a layered 2D board of tiles, sort of like a grid. So, you can see everything that's going on in the game right there on the board, essentially. And then the changes in the state. So the game state is sort of a 2D grid of tiles, right? And the changes in the state are accomplished by just using tile rewrites, which are essentially just a visual representation of replacing one arrangement of tiles with another arrangement of tiles. So you can see sort of all the rules and how things change in the game as well, very visually. And the control flow, the way that, the logic is handled for the game, loops and things like that, is handled by behavior trees, which are sort of a popular approach for visual programming, usually for like agent behavior in games. But in this case, we're using the behavior trees to control sort of like the logic of the entire game, right? So we're taking the rewrite rules, the tile rewrite rules, and the behavior trees, kind of putting them together and making sort of domain-specific language for games we're calling tile rewrite rule behavior trees. And we're interested in kind of seeing what kinds of games that we could develop in this language. And so one of the things that we were looking at was, could we build a roguelike using tile rewrite rule behavior trees, TRBTs, right? So we'll talk a little bit more about the language and then a little bit how we've been looking at implementing a roguelike. So one of the main things in the language is tile rewriting, and this is basically taking a left-hand side sort of arrangement of tiles and then replacing that with a right-hand side arrangement of tiles, so something gets replaced with something else, and that's how things change in the game state. So, for example, we could take the player tile and a blank tile and replace that with a blank tile and the player tile, and that would be a way of representing basically player moving into a blank spot. And then we could also say we'll take a rectangle of solid tiles and replace that with sort of some empty space in the middle, and this would be like placing a room, essentially an empty room, right? And so we can represent various different things with tile rewrites. And in addition to changing things in the state by rewriting tiles, we can also sort of examine the state and see what's in it. So if we wanted to see if the player has found the gem, right, that they're trying to find in the game, we could just check and see, is there a gem tile somewhere on the board? And that would be like sort of matching a tile pattern and seeing if it's there. And we could use that for further logic in the game. And then the way that this is all sort of combined together and tied together is through behavior trees. These are, again, oftentimes used for sort of programming agents in games. We use similar concepts. Some of the nodes are not all exactly the same as the standard ones that people use, but they're basically a tree of nodes, and the nodes can run, and they succeed or fail, and then depending on the type of the node, they customize their behavior depending on whether the children of this particular node succeed or fail, right? So here's a sort of a simple start of a behavior tree where we've got an order node with two children, one of which is another order node, and then a loop until all node. And basically, the order node just runs all the children in order once, and the loop until all node will kind of loop through running its children over and over again until all of the children fail, and then it will be done running. So here's expanding that out a little bit. Right on the left-hand side, we've got the order node with its children, and basically just going to go through those in order, set the board to be all solid tiles, do one rewrite to make kind of like an empty room somewhere, then rewrite one of those blank tiles with a player and one with a door to put the player and the door, the exit, in some random place in the room. And then the loop until all node has a little bit more involved set of children, but the xspin basically says everything under here is going to it doesn't matter which order it happens in, and then the player node means the player who's the person playing the game gets to decide which one of these rewrites they want to apply, and they can either move the player tile into an empty space, or they can move it onto the door, and that will turn it into a gem, make the gem appear basically. And then going further over to the right, the player wins if there's a match of the gem somewhere on the board. So that's basically when the player wins, if there's one of those anywhere, right? And with basically that behavior tree right there, that TRRBT, you get a really simple sort of game like this, where there's just a little room and the player can walk to the exit and find the gem, right? So we started with something kind of like this, and we want to build up to add some more complex features to this roguelike style of game. And one of the things that actually inspired us quite a bit was this game called Roguel, which is a daily roguelike, every day a different sort of dungeon to explore. And it's emoji based, so the tiles and things like that are all emoji based, and this was kind of part of the inspiration for the game that we were working on, which we're calling Trogue. And it's a fairly simple roguelike with dungeon generation, exploration, enemies, combat, collectible items, and all using also emoji tiles. This works well with the tile rewrites. So I'm going to look at the TRBT implementation of some of these features. And in particular, we'll be looking at kind of like a debugging view with more animations and more tiles kind of visible than what the player sees while they're playing. But this is like a little video of some of the gameplay, right? Like collecting a wand and exploring the dungeon, and there's enemies, and you can cast fireballs to fight the enemies. And if you get too close to the enemies, they do damage as well. So you can see there's health in the bottom left as well. The game makes pretty extensive use of some of the language features of layers and hidden tiles. So layers basically let you stack tiles one on top of each other, so you can show more than one thing at the same place, or keep things associated with each other. And also, if you put a larger tile above a smaller one, you can use that to hide them during gameplay. And then there's also just sort of tiles that are completely hidden from the player, that are sort of tagged with this underscore, and you can only see them when debugging. And there we use those a lot for tracking kind of like hidden state, things that shouldn't be visible at all to the player, but are useful for tracking things and useful to see when you're debugging. So of course, one of the first things that we wanted to do was generate a random kind of dungeon for the player to explore, and doing this essentially only with like being able to rewrite tiles and kind of control the logic of them with the behavior tree. And so the first thing it does is it kind of like stamps out all the different rooms, similar to before, but the rooms also have like a seed tile marking their center. And then we can randomly pick one of those rooms and start kind of pathfinding out from that room by rewriting sort of empty tiles in a particular layer with arrows kind of pointing in towards the center of the room, or pointing in towards the other arrows that are pointing in towards the center of the room, and iteratively growing this kind of pathfinding structure out until we hit the center of another room, and then just follow it along to clear a pathway. And then we end up with some rooms and some hallways between them. There's also a HUD, or a heads-up display, that has the elements to show for the player's health in their inventory, which is the hearts and the wands. And because everything is just somewhere on the board, the way that we get them in the right place in the corner is just kind of drop them on the board, and then move them all the way over and all the way down until they get into the right place, and then expand out the sort of the meters, the health meter and the inventory meter from there. This is kind of, I thought this was kind of interesting because, right, everything has to be spatially located somewhere on the grid. And then we also have exploration and fog. So there's like a layer essentially on top of everything else with the big square emojis that will, visually hide everything underneath them. And then every time the player moves, we sort of do a similar approach as before, where we kind of iteratively find, by rewriting, tiles next to the player or next to tiles we've already found, the locations that are near to the player. And then we can use this to clear away sort of like the darkness tiles and the fog tiles. And the fog refills every time the player moves, but the darkness doesn't. So the fog kind of follows them around, and you can't, see stuff that's happening in areas far away from you. There's also enemy movement. There's two types of enemies that move differently. The bats move randomly, and the snakes patrol back and forth. And so the snakes have these little hidden, you can see they've got kind of like the underscores by them. They've got these hidden arrow tiles underneath them that keep track of which direction that they're moving. And there's a special layer to sort of keep track of kind of like the information about the enemies, like if they've moved this turn, which direction they're going, and that kind of thing, if they've attacked and so on. And then when the enemies do attack and they do damage, we need to remove some health from the player. The bats do 1 damage, the snakes do 2 damage. And the way we did this here is whenever some damage is done to the player, we just randomly remove the appropriate number of hearts from the health meter there at the bottom, and then kind of shift everything down so that, the health meter is still contiguous. And again, this is sort of, the player doesn't actually see this, but this is kind of slowed down for demonstration. And if the player doesn't have any hearts left, then they lose the game. And then the player can also attack and fight the enemies. They have wands, and if they have a wand, they can cast a fireball. And for the way that the game works, you have the arrow keys to move the player, and then there's also an action button. And when you press the action button, that kind of tracks that, okay, now the player has cast a fireball, and that's done on a special layer. And then if they've done that, then the next time you press the arrow key, then that launches the fireball in a particular direction. And again, one of these sort of extra auxiliary hidden layers keeps track of the direction that the fireball is going with these little arrow tiles here as well. And so, here's some screenshots of the tree, the behavior tree, basically, that is how it is currently. It has, like the simpler example at the beginning, it's kind of got 2 main subtrees, one for generating the dungeon and then one for sort of the player playing. And if you expand it all out, it looks like that. That one down there at the bottom, quite a lot of nodes, but they can visually be collapsed and hidden, and so it's relatively straightforward to kind of just like focus on the particular area that one is working on at a time. And there's also, they have comments and that kind of thing that can help navigate through it. But that's kind of all of the code basically for the game itself, essentially, right there. So in summary, we have been developing Trogue, which is a simple roguelike implemented using this new sort of domain-specific language we've been developing called Tile Rewritable Behavior Trees, or TRRBTs. There's a bunch of other stuff that might be interesting to kind of add to it in the future. Of course, more item types, more spells, different types of enemies having maybe more than 1 health, different mechanics like locks and keys, teleporters might be kind of interesting, tracking progress between floors. Now, every time you get to the exit, you just start over, essentially, and some balancing maybe between like how many enemies there are and how many wands there are, and that kind of thing, to maybe make it easier or harder. So that's it for what I was going to present. So thanks for inviting me, and thanks for listening to my talk. I'm Seth Cooper. There's my email and website, and you can play the game. I put it on itch as well if you'd like to give it a try. And I want to especially thank Kayla, Cynthia, Jai, and Chris for their help. And the Corey College of Computer Science is a research seed grant for their help and some support developing the underlying language and that kind of thing. And there's a couple of papers too that you could take a look at if you are interested in finding out a little bit more details and that kind of thing. Thanks.
Excellent. Thank you so much. I'm going to try and sneak in just like a bit of a quick question because I am curious because it might be that the answer is yes, it's in the paper. Dr. G asked about if you did any kind of user study, dev studies to see how people find this rewriting based programming compared to like traditional imperative programming of like, is it more accessible? Is it just kind of creative and fun? Is it that works for some people, not others? Like, is that something that comes up in the paper?
Yeah, the second paper we did a little bit of a kind of small scale kind of user study, and I think kind of one of the interesting things that we found is that it's not it's different from other kinds of programming in that um, the tiles don't really have like an identity, so to speak, right? Like the little player tile is not doesn't have like it's just an emoji of the player, right? And so anything that um, any rewrites that have that tile in it could kind of apply to any tile with the player in it, right? It's not like, an object of the player or something
Right.
like that existing on the board. Um, it's just a tile, and then
Yeah,
the
it's just
rewrites
the
and
same
things
as
like
any other
that can
tile.
apply to it just as they could to, a fog tile or a wand tile or a fireball tile or something like that. So there's some indication maybe that it's a different way kind of thinking about um, uh, how to structure the things that
Yeah, that's
the
a good
game
point.
and how
That's a
they
very like
change.
base
So
level
that's kind of interesting.
assumption to have to lose of like, no, even the player character is not like a special object. It's just another tile. Like everything's just tiles. Excellent. Well, thank you so much
Yeah.
for fitting that into 15 minutes, and I am definitely looking forward to going and following up on that paper. So thanks so much
Thank you
for
very much.
coming to Roguelike Celebration.
Yeah.